concepts completed. Basic proportionality theorem as well as converse of basic proportionality theorem. The two theorems also completed. Next one is similarity of similar triangles. Side, side, side. Angle, angle, angle. Side, angle, side. The similarity is also completed. Now I am going to start third concept in this chapter. This is last concept in this chapter. That is Pythagoras theorem. We have only Pythagoras theorem concept. Converse of Pythagoras theorem also there. That is deleted. That is deleted. So if you learn Pythagoras theorem, that is enough. Again, so I think you know already Pythagoras theorem very well. So many problems we use that formula. Is it right? In applications of trigonometry, quadratic equations, sometimes so many chapters we will use Pythagoras theorem formula. Once tell me the formula for the Pythagoras theorem. What is the formula of Pythagoras theorem?
Hypotenuse square equals to opposite square plus adjacent square.
Very good. Opposite square, hypotenuse square equal to opposite square plus adjacent square, or hypotenuse square equal to base square plus height square. Hypotenuse square equal to base square plus height square. So this Pythagoras theorem are also known as Bahudayana theorem. Pythagoras theorem are also known as Bahudayana theorem. Again, what is the another name of Pythagoras theorem?
Bahudayana theorem.
What is the another name of basic proportionality theorem?
Thales theorem.
Thales theorem. Thales theorem or basic proportionality theorem or BPT theorem. These three names is only one meaning. Next, coming to Pythagoras theorem are also known as Bahudayana theorem. Pythagoras theorem are also known as Bahudayana theorem. This Pythagoras theorem says that in a right angle triangle, this is one right angle triangle ABC. ABC is the right angle triangle. In a right angle triangle, the square of hypotenuse. What is meant by hypotenuse? What is meant by hypotenuse?
Longest side of a right angle triangle.
Very good. Longest side of a right angle triangle or
opposite side to 90 degrees.
Opposite side to 90
right
degrees.
angle opposite side. Right angle opposite side or longest side in a right angle triangle. Then it is called hypotenuse. This Pythagoras theorem says that in a right angle triangle, given condition is it is a right angle triangle. In right angle triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. So these two are other two sides, base and height. Sum of the squares of the other two sides. Sum of the squares of the other two sides. The square of hypotenuse, hypotenuse is AC. The square of hypotenuse is equal to the sum of the squares of the other two sides, AB and BC. Is it clear? Pythagoras theorem statement?
Yes, sir.
Yes, sir.
Once tell me Pythagoras theorem statement. In a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. Simply we can say that hypotenuse square equal to adjacent square plus opposite side square, or hypotenuse square equal to base square plus height square, right? The base square plus height square is nothing but sum of the squares of other two sides. Hypotenuse square is nothing but the square of hypotenuse. This is the Pythagoras theorem statement. The square of hypotenuse is equal to the sum of the squares of the another two sides in a right angle triangle. Given condition is, if it is a right angle triangle, given triangle is the right angle triangle, then prove that hypotenuse square equal to opposite side square plus adjacent side square. That is the Pythagoras theorem statement. Converse of Pythagoras theorem says that in a triangle, if it is not right angle triangle, given that in a triangle, the square of any one side of a triangle is equal to the sum of the squares of the other two sides. Then prove that the triangle is the right angle triangle. That is converse of basic proportionality theorem. Converse of Pythagoras theorem. So Pythagoras theorem is the square of hypotenuse is equal to the sum of the squares of the other two sides. Here given condition is triangle ABC is the right angle triangle. Is it clear? Statement of Pythagoras theorem.
Yes, sir.
Tell me, anyone? Bhargav, tell me. Statement of Pythagoras theorem.
Yes, sir. In a right angle triangle, the square of the hypotenuse is equals to the sum of the squares of other two sides.
Very good. Sum of the squares of the other two sides. Yeah. So here, given condition, given that, given triangle ABC is the right angle triangle. Triangle ABC is an right angle triangle. Right angle triangle. Right angle triangle at point B. At point B. This is given. Again, a triangle ABC is the right angle triangle at the point B. Then prove that RTP required to prove. Then prove that the square of hypotenuse is nothing but AC square is equal to the sum of the squares of the other two sides is nothing but base square AB square plus height square BC square. This is the RTP required to prove. Hypotenuse square equal to adjacent square plus opposite square, or hypotenuse square equal to base square plus height square. Both are same meaning only. Again, triangle ABC is the right angle triangle is given. If it is right angle triangle, then prove that hypotenuse square equal to base square plus height square. That is RTP. Now, here I am doing small construction. That construction is from this point, from this vertex B, to draw one more perpendicular line that is perpendicular to AC. If BD is perpendicular to AC, then here total triangle ABC is divided into two right angle triangles. In that first right angle triangle is ADB is the first right angle triangle. Similarly, second right angle triangle is CDB is the second right angle triangle. Is it correct? If you
Yes,
draw
sir.
a perpendicular line from the vertex B, if you draw a perpendicular line from vertex B to D, B to D, BD is the perpendicular to AC, then this total big right angle triangle ABC is divided into two right angle triangles. That is ADB is the first right angle triangle, CDB is the second right angle triangle. So here small construction. That construction is BD is perpendicular to AC. BD is perpendicular to AC. Now proof of the Pythagoras theorem. Once all of you listen carefully. Here this total big triangle ABC is divided into two right angle triangles. That first right angle triangle is ADB. Second right angle triangle is CDB. Is it right? Now here you should take one big triangle ABC. Take big triangle ABC, big right angle triangle ABC, and take first small right angle triangle. What is the first small right angle triangle?
ADB.
ADB. Take that triangle. ADB. ADB. Here right angle is D. Next A. These two common angles you should write. Again, a common angle is nothing but corresponding angles. You should write corresponding places only. In this base is A, then corresponding angle here also you should take A. In second triangle, upside is C is there. That's why in second case you should take upside only, that one. So in this right angle triangle, big right angle triangle is the ABC, and first small right angle triangle is ADB. ADB. Then prove that these two triangles are similar. If these two triangles are similar, corresponding sides are in proportion. Very simple amount. Angle A equal to angle A, common angle. Is it right? Angle B equal to angle D, right angle.
90 degrees.
90 degrees. By using angle similarity, triangle ABC is similar to triangle ADB. Triangle ABC is similar to triangle ADB. Is it right? Ma, angle
Yes,
A
sir.
is the common angle. Ma. Angle B equal to angle D, 90 degrees. By using angle similarity, these two triangles are similar. The two triangles is nothing but ABC is similar to triangle ADB. Then these two triangles are similar. Corresponding sides are in proportion. What are the corresponding sides? Height by height, base by base, hypotenuse by hypotenuse. Then tell me, big triangle height is what here? BC. BC by, in small triangle height, BD equal to, in big triangle base, AB.
AB by
Small
AD.
triangle base, AD equal to, big triangle hypotenuse is AC. Small triangle hypotenuse is AB. From these three corresponding sides, you should identify, you should take only two corresponding sides. The two corresponding sides, from the two corresponding sides, one side should be same. One side should be same. BC. BC indulo inkekanena unda chudandi. BC లేదు. BD లేదు. AB. ఇక్కడ ఉంది చూడమ్మా. AB. That's why you should take only these two corresponding sides. Remove this third corresponding side. Is it clear? You should take only two corresponding sides. That is, okay now. So from the two corresponding sides, one side should be same. Why? Because we should prove that square. When you will get the square, if two corresponding sides are equal, then if you multiply these two sides, AB into AB, then you will get AB square. That's why take two corresponding sides only. In the two corresponding sides, one side must be equal. That's why you should take only these two corresponding sides. From these two corresponding sides, then do cross multiplication. AB into AB, AB square equal to AD into AC, AD into AC only. Is it clear? This is equation number 1.
Yes, sir.
Half of the part completed, Amma. Proof. Is it clear? Is any doubt?
Clear, sir.
Now, next, second case. In second case also same. Take total big triangle. And now you should take second small right angle triangle. And then tell me total big triangle is the triangle ABC only. A, B, C. And what is the small second right angle triangle? CDB. So small second right angle triangle is, here C is upside is there. That's why here also you should take C. Here right angle at the point D. C is completed. D also completed. Third vertex is B. B. These two must be same. Okay, now then prove that these two triangles are similar. Angle C equal to angle C. Angle C equal to angle C, common angle. Angle B equal to angle D. Angle B equal to angle D. That is 90 degrees, right angle. That's why by using angle similarity, we can say that triangle ABC is similar to triangle BDC. ABC is similar to triangle BDC. Then these two triangles are similar. Corresponding sides are in proportion. What are the corresponding sides? Height by height, base by base, hypotenuse by hypotenuse. Height BC. First big triangle height BC. By small triangle height CD. Equal to big triangle base AB by BD. Hypotenuse AC by BC. From these three corresponding sides, then tell me what are the
Sir.
two corresponding what we need in these three corresponding sides?
BC by CD equals to AC by BC.
Here BC is there. In last corresponding side also BC is there. We should take these two corresponding sides only. Third one is just cancel. BC by CD equal to AC by BC. Then do cross multiplication BC into BC. BC square
BC square equals to AC into CD.
CD into AC. This is equation number 2. Equation number 2. Is it clear?
Clear, sir.
Now add equation number 1 and equation number 2. Add equation number 1 and equation number 2. Add left side conditions, left side only. Right side conditions, right side only. Left side conditions are is what here? AB square.
AB square plus BC.
Plus AB square plus BC square. AB square plus BC square equal to right side conditions AD into AC
Plus CD
here right
into
side
AC.
condition CD into AC. From these two conditions AC take AC as a common. The remaining terms are AD plus
CD.
From the figure AD plus CD, so this is the first side AD, this is the second side CD. AD plus CD. Sum of these two sides equal to
AC.
total side. The total side is AC. AC into AC. That is AC square. Therefore, AB square plus BC square equal to AC square is nothing but hypotenuse square equal to opposite square
Opposite
plus
square
adjacent.
plus adjacent square.
This is the proof of Pythagoras theorem. Is it clear?
Yes, sir.
Is it clear, all of you?
Clear, sir.
Yes.
Is it clear? Amma?
Yes, sir.
Shall I explain one more time? If anybody want one more time explanation, I will explain one more time also. If you want, if you need one more time explanation, tell me. I don't have time.
No need, sir.
No, sir.
Very simple. Very simple. Okay, now in triangle, right angle triangle ABC is given, then prove that hypotenuse square equal to base square plus height square. Construction, draw the perpendicular line. BD is perpendicular to AC. If you draw BD is perpendicular to AC, here this total right angle triangle is divided into two right angle triangles. That is, first right angle triangle is ADB, second right angle triangle is CDB. Then take first big triangle, triangle ABC, and first part ADB. Then prove that these two triangles are similar. Corresponding sides are in proportion. In that corresponding sides, you should take only two corresponding sides. The two corresponding sides also, one side must be equal. AB into AB, AB square equal to AD into AC. Next, take again big triangle, second part. Second part is what here? CDB. CDB. Triangle ABC is similar to triangle BDC. If these two triangles are similar, corresponding sides are in proportion. Height by height, base by base, hypotenuse by hypotenuse. From these three corresponding sides also, you should identify only two corresponding sides. In the two corresponding sides, one side must be equal, that is BC and BC. Take these two corresponding sides only. From these two corresponding sides, do cross multiplication. BC into BC, BC square equal to CD into AC. This is equation number 2. Now add equation number 1 and equation number 2. So add left side conditions only. AB square plus BC square left hand side conditions equal to right hand side conditions are AD into AC plus CD into AC. Now from these two conditions AC, take AC as a common. The remaining terms are AD plus CD. AC into, from the figure, AD plus CD. Sum of these two sides equal to total side AC. AC into AC, AC square. Therefore, AC square equal to AB square plus BC square. This is the proof of Pythagoras theorem. Is it clear?
Yes, sir. Sir, once can
Yeah.
you tell the statement of a converse of Pythagoras theorem, sir?
Okay, I will explain. So, once tell me statement of Pythagoras theorem first.
In a right angle triangle, the square of hypotenuse is equals to the sum of squares of other two sides.
Other two sides, right? So converse of Pythagoras theorem, converse means reverse. If it is not right angle triangle, in a triangle, the square of any one side of a triangle, here hypotenuse is not given. If they will give hypotenuse, the triangle becomes a right angle triangle, right? That's why they're not given. The square of any one side of a triangle is equal to the sum of the squares of the other two sides. Is equal to the sum of the squares of the other two sides. Then prove that the triangle is the right angle triangle. Here, right angle triangle is given. We proved that hypotenuse square equal to base square plus height square. In converse of Pythagoras theorem says that hypotenuse square equal to base square plus height square. Then prove that the triangle is the right angle triangle. And it's but hypotenuse and మనం అనొద్దు directly. ఎందుకు? అది right angle triangle అయితేనే hypotenuse అవుతుంది కదా, right angle opposite side. వాడే right angle triangle అని ప్రూవ్ చేయమన్నప్పుడు ఫస్ట్ మనం పైథాగరస్ థీరం మనం రైట్ యాంగిల్ అని ఎలా తీసుకోవడానికి ఛాన్స్ లేదు కదా. కాబట్టి ఏం చెప్పాలి? ద స్క్వేర్ ఆఫ్ ఎనీ వన్ సైడ్ ఆఫ్ ఎ ట్రయాంగిల్, ఈస్ ఈక్వల్ టు ది సమ్ ఆఫ్ ది స్క్వేర్స్ ఆఫ్ ది అనదర్ టూ సైడ్స్. Then prove that the triangle is the right angle triangle. Is it clear? Converse of Pythagoras theorem?
Yes, sir, clear.
But converse of Pythagoras theorem is deleted. So that's why if you learn only Pythagoras theorem is enough. Once tell me what is the another name of Pythagoras theorem?
Baudhayana theorem.
Baudhayana theorem. Yes, write down this proof of the Pythagoras theorem. First, all of you write down statement. Keep heading statement. Write down statement. Then after write given RTP construction proof. Otherwise, take screenshot.
Done.
Completed?
Yes, sir.
Yeah. Next question. Once all of you open exercise number 8.4. 8.4. In 8.4, first question. Jayani, read that question. Ma, are you there?
Yes, sir.
Jayani, once read that question number 1 in exercise number 8.4.
Can I read, sir?
Read.
Prove that the sum of the squares of the sides of a rhombus is equals to the sum of the squares of its diagonals.
Prove that sum of the squares of the sides of a rhombus. Prove that sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonal. Shall I rub this board?
Yes, sir.
Rhombus. What is mean by rhombus? Tell me the definition of rhombus.
Sir, all sides are equal.
All sides are equal and diagonals are perpendicular to each other. Diagonals are perpendicular to each other. So take one rhombus. This is one rhombus. A, B, C, D is the rhombus. In this rhombus, all sides are equal, right? All sides are equal. Our question is prove that sum of the squares of the sides of a rhombus. Sum of the squares of the sides of a rhombus is nothing but AB square plus BC square plus CD square plus DA square. Sum of the sum means addition. Sum of the squares of the sides of a rhombus. Sum of the squares of the sides of a rhombus is nothing but AB square. Next side BC square plus CD square plus DA square. Prove that sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Sum of the squares of its diagonals. What are the diagonals here? AC is the first diagonal.
AC and DB, sir.
DB or BD is the second diagonal. Equal to AC square plus BD square. This is the required proof of the given question. Prove that sum of the sum is nothing but addition. Sum of the squares of the sides of a rhombus. Sum of the squares of the sides of the rhombus is equal to the sum of the squares of its diagonal. Is nothing but AB square plus BC square plus CD square plus AD square is equal to the diagonals AC square plus BD square. Is it clear?
Yes,
is
sir.
It clear? Question is clear. First of all, question ardhamaina?
Clear, sir. Yes, sir.
So here in this rhombus, diagonals are perpendicular to each other. That's why this total rhombus is divided into these two diagonals intersect at the point O. Okay, so this total rhombus divided into how many right angle triangles? This is the first right angle triangle AOB. This is the second right angle triangle BOC. This is the third right angle triangle COD. And DOA is the fourth right angle triangle. Then this rhombus is divided into how many right angle triangles?
4 right angle triangles.
4 right angle triangles. From these 4 right angle triangles, apply 4 times Pythagoras theorem. In triangle AOB, apply Pythagoras theorem. In triangle BOC, apply Pythagoras theorem. In triangle COD, apply Pythagoras theorem. In triangle DOA, apply Pythagoras theorem. You will get 4 equations, right? Then add that 4 equations,
yes,
you will get the answer. Will you do this problem?
Yes, sir.
Try. At least try this problem. Very simple, Amma. Just here 4 right angle triangles are there. Apply 4 times Pythagoras theorem. That's all. In first triangle, AB square equal to AB hypotenuse right angle. Here it is the right angle. Right angle opposite side is AB. AB square equal to OB square plus OA square. That is equation number 1. In second triangle BOC, right angle is O, right angle opposite side is BC. BC square equal to hypotenuse square equal to base square plus height square. OB square plus OC square. That is equation number 2. In third right angle triangle, hypotenuse is the CD. CD square equal to OD square plus OC square. Last right angle triangle, hypotenuse is AD. AD square equal to OD square plus OA square. That is the fourth equation. Now add that 4 equations. Left hand side conditions are left hand side only. Right hand side conditions are right hand side. Then do simplification. You will get the answer. Will you do? Why? Because we have only 30 seconds a time. Otherwise, I will explain tomorrow. Just try. దీనికంటే ముందు మాత్రం ఖచ్చితంగా ప్రతి ఒక్కరు కన్స్ట్రక్షన్ చేసి నాకు ఈ రోజు వాట్సాప్ లో పెట్టాలి. Is it clear అమ్మా? Is it clear all of you?
Yes, sir.
I think నాకు ఏమనిపిస్తుంది అంటే మీరు క్లాస్ వింటున్నారా లేకుంటే జస్ట్ ఆన్ చేసి పక్కకు పెట్టిరా? చెప్పండి అమ్మా.
Listening, sir.
Listen, all of you listen. Is it clear all of you?
Yes.
Okay, right.